Hey guys, Coach Moss here. So I wanted to take a second to backtrack on long and synthetic division. Overall, we did a really good job. There was a couple different things I just wanted to touch on. A few people made like the same mistakes with. So I'm just going to go through solving one long and one synthetic division. A couple things that you need to make sure that you do is setting it up correctly. I've had a lot of people making mistakes just setting it up. And then solving correctly. If you're doing long division and you're subtracting, that you are using that subtraction sign to each piece of the equation individually, and then what to do with the remainder when you have it. Quite a few people just put like remainder is this, and that's not how it's supposed to look. I still gave credit to those of you who solved correctly, but I also want to make sure that you are answering the question correctly when you have a remainder. So let's look at our first one here. First thing you should notice is that there's no x. So when you're setting up long division, you have to set up x cubed plus 8x squared plus 0x. You always have to include it, even if there is not one there, because it'll come in, like you'll still need it when you're dividing, even if it's 0. All right, and then we have x squared plus 3x minus 3. All right, so my first is going to be x, because in order to get x3, I have to multiply x squared by x. So that gives me x cubed plus 3x squared minus 3x. Now, again, this is where I said that the subtraction sign is super important, that you basically look at each one individually with the subtraction sign. So we have x cubed minus x cubed, that gives me 0. 8x squared minus 3x squared, which is going to give you 5x squared. And then you have 0 minus negative, which should make it positive 3x. All right, because you're subtracting a negative. And then we bring down the 5. And then in order to make x squared, 5x squared, we would multiply it by 5. We will multiply everything by 5. Which gives me 15x and then minus 15. All right, again, each one individually with the subtraction sign. 5x squared minus 5x squared, 0. 3x minus 15, that gives me negative 12x. And then you have negative 5 minus negative 15, which is the same as plus 15, which will give me a positive 10. This is your remainder. A lot of you just left it here and was like, oh, it's x plus 5 with a remainder of negative 10x plus 10. But when you write it out, it is technically part of the equation still. So you can put an addition sign if you'd still like, but you will put that remainder, negative 12x plus 10, over whatever you divided by. X squared plus 3x minus 3. You will always take your remainder and put it over your polynomial in fraction form, and that would be the correct answer there. All right, let's move on to synthetic division. Now, when I do synthetic division, I think about things a little bit differently. First things first, we have to make sure that we are using negative 6 and not positive 6. Since it is x plus 6 equals 0, our 0 is negative 6. All right, so we have negative 6 here, 3, 15, and make sure that you always carry your negatives. All right, I'm going to bring down this 3 here. That gives me negative 18. Now, something that a lot of people did here was they were thinking that they're subtracting, and so they would add 15 and 18 because they're thinking that they're subtracting a negative, but they're not. Okay, when you're doing synthetic division, you're just looking at, when I combine these, 15 and negative 18, what do they become? Negative 3. So a lot of people got 33 on that one. It should just be negative 3. Okay, negative 3 and negative 6 gives me 18, and that gives me negative 10. The second thing here, so this 3 is technically an x squared, this 15 is an x, and the negative 28 stands alone. When you're doing synthetic division and you move down a line, every time you move down a line where you're finding products, it removes an x. So this would actually just be 3x minus 3 minus 10 or plus negative 10 over x plus 6, okay? And that would be our synthetic division.